If we keep adding solid to a liquid, eventually we'll reach the point where some of the dissolved solute recrystallizes and the solution reaches a dynamic equilibrium, where we have two opposing processes occurring at the same time, and at the same rate as noted by the double arrow. A solution that's at equilibrium with its undissolved solute is said to be saturated. When a solution is saturated, you can add more solute, but it won't dissolve. Different compounds have different solubilities. It takes different amounts of solute to dissolve in a given amount of water. Anything less than that, and our solution is unsaturated. A third type of solution can be formed under the right conditions where more solute is dissolved than is needed to form a saturated solution. These solutions are said to be supersaturated, and they're very unstable, as we'll see in a demo. We've learned that like dissolves like. Polar liquids tend to dissolve in polar solvents. Substances that dissolve in each other are miscible, like water and acetone, which does have a polar end. Unlike water and gasoline, which is a nonpolar compound, these two substances are immiscible. This chart shows the solubility of some alcohols. All alcohols have a hydroxyl group with hydrogen bonding, which should make them soluble in water. But the longer that carbon chain gets, the more nonpolar that molecule is, and the less effect that hydroxyl group will have on the entire molecule. So, the more carbons in the alcohol, the less soluble it will be. Although the solubility of solids and liquids aren't affected much by pressure, the solubility of gases are. Gases in a solution with a liquid also form a dynamic equilibrium. As some gas molecules escape from the solution, others will move back into the solution. If we increase the pressure above the solution, more gas molecules are forced back into the solution. Think about a bottle of soda. It's pressurized to keep the fizz in. When you open up the bottle, you release the pressure, and the carbon dioxide bubbles out. This relationship is described by Henry's law, which states the solubility of a gas increases in direct proportion to its partial pressure above the solution, where K is a proportionality constant. Temperature also has an effect on solubility. For most solid solutes in water, the higher the temperature of the water, the more soluble the compound, with at least one exception. Ever notice how hard it is to dissolve sugar in iced tea? The opposite is true for gases dissolved in a liquid. The higher the temperature, the lower the solubility of the gas, which is why soda will go flat much faster on a hot day.